Today, I'd like to go through solving problems with the speed of sound. This was something I had asked you to do in the previous video, but a few people had trouble figuring out how to attack it. And part of that is my fault. We have to rely on a formula that we had from earlier in the year, and I didn't explicitly state that in the last video. So let's work through this problem together. So here we have a person who got a great video of the demolition of a bridge. And what we'd like to do is see if we can figure out how far away the person is from the site of the explosion. You'll notice we need to know the temperature on the day of the explosion, and we're going to use that to find the speed of sound. Then here's where I did not give you the formula, but it's one that we've used before. You're going to use the speed of sound as your velocity, and you're going to do velocity equals displacement over time. You also, alternatively, could just use speed equals distance over time, and you can use either formula because our object, this time sound, is traveling in a straight line, so the distance and the displacement will be the same. So let's watch our video.
Oh, I missed it.
And it is clear that you do not hear the explosion at the same time that you see it. So you see the explosion, and then you hear the explosion. So what I did is I took the video into video analysis. I found the frame at which the explosion first began to occur, and you can see it's 4.22 seconds. Write that number down. That is the start of the sound wave. It takes place at the 4.22 second mark. I then brought the video into iMovie and I looked down here at the sound and I can see when the sound spikes. I then compared the two videos and found that the sound arrived at the 7.26 second mark. So the sound started at 4.22. It arrived at 7.26. So it took a total of 3.04 seconds for the sound to travel from the bridge to where this person was filming. We then realized that the speed of sound is in air. So in air, we have a formula that says velocity of sound equals 331.5 plus 0.6 times the temperature. The temperature on this day was 15 degrees. We plug this into our calculator and we get around 340 meters per second. We now have everything we need to solve this problem. So we go back to our video. We use one of our velocity equations. I'm going to mix and match. We plug in the 340. We plug in the time. And we solve for the distance. You should get a little bit over 1,000 meters. So it's a little more than 1 kilometer. Work through it and get the exact number of meters. I just wanted to show you roughly how to work through these problems. Let's do one more where we're working backwards. This time we have Mr. McCarron exactly 75 meters away from the camera. Using the video analysis, we find that it takes the sound 233 milliseconds to reach us. When he hits the drum and when the sound arrives at our location are off by a little more than 0.2 seconds. So we're going to start with our formula, velocity equals distance over time. We're going to plug in the 75. We're going to put our time in seconds, and we're going to get an answer for our velocity. Please work through this on your calculator. You should get somewhere in the 300 meter per second mark. I'm not going to give you the exact number. You can work that out. Then you take that number, you plug it into the velocity of sound equation, and you solve for temperature. If all goes according to plan, and again, I'm not going to give you the exact number, but you should get a temperature a little bit less than 10 degrees Celsius. The temperature on this day was in the 40s in Fahrenheit and a little less than 10 degrees Celsius. I hope this video helped you tie together sound stuff with the stuff that we did earlier this year.